to the angle B is x, divided by the hypotenuse, which is denoted by small letter a. When x is made the subject of the formula, x is going to be equal to a multiplied by the sine of the angle at B. So like the answer was given to me, x is equal to a sine B, we are going to reserve it and label it as equation number 2. Like we did in the specific case, when we look at the two equations, the first one states that x is equal to b sine a. The second one also is stating that x is equal to a sine b, where this x is the same x as that one. So the two expressions equal to x must be equal to each other. So we come up with the relationship stating that b sine a is equal to a sine b. This relationship we have come up with is what is known as the sine rule. All we are going to do is we are going to manipulate it so that it appears in a form that we can easily remember. Remember, this is an equation. What you do on one side of the equal sign, you must be in a position to do on the other side. So I am going to divide both sides of the equal sign by a multiplied by b. So on the left hand side, I will divide by a multiplied by b. What I have done on the left hand side, I will do on the right hand side. I will divide by a multiplied by b, so that our equation remains balanced. It is very clear at this point that b and b will divide to give us 1 there and 1 there. On the right hand side, a and a will divide to give us 1 there and 1 there. Meaning, on the left hand side, the expression will be sine a is divided by a, which is equal to, on the right hand side, the sine of b is divided by b. As I said, all we have done is we have expressed the sine rule in a manner which is easier to remember, because it will be a question of you recalling that the sine of an angle A must be divided by the side opposite the angle A, and this should be equal to the sine of the angle at B divided by the side opposite the angle at B. So at this point, we are going to realize that even if we were to use the side B and the side C, we were going to come up with an expression as sine B over B is equal to sine C over C. Similarly, if we were to analyze using the side C and the side A, the relationship should have been sine of angle A over the side A is equal to the sine of angle C over the side C. Therefore, in general, we are going to state that for any triangle ABC, for any triangle ABC, the sine rule states that the sine of the angle A, when divided by the side A, is equal to the sine of the angle at B divided by the side opposite that angle, and this ratio is equal to the sine of the angle at C divided by the side C, which is opposite to the angle at C. The beauty about the sine rule is that it can be remembered in two different ways. So this same one can be written as A as a side divided by the sine of the angle at A is equal to B as a side divided by the sine of the angle at B, and is equal to C as a side divided by the sine of the angle at C. I don't expect this to confuse you, because it is true, like when we look at two simple fractions, that if 2 over 3 is equal to 4 over 6, which is a true statement, because when 4 over 6 is reduced to the lowest terms, you will get 2 over 3. From this true statement, it is possible to come up with another true statement whereby the denominators now will become the numerators, and the numerators will become the denominators. So, from this, it is true that 3 over 2 is equal to 6 over 4. That is why I said the sine rule is so easy to remember, because you can remember it in two different ways. If you want, you can have the sines of the angles as the numerators, then the sides opposite those angles as the denominators, or you can have it the other way around. So at this point, having derived the sine rule, I want us now to move on and look at examples in which the sine rule is going to be used. Our first example involves a triangle PQR, in which the angle at P is 60, the angle at R is 50, and we are given a side PQ as 5 centimeters. I want you to use the capital letters P, Q, and R, and the small letters P, Q, and R, and state the sine rule in as far as this triangle is concerned. Exactly. Either you can state to say small letter R divided by the sine of capital letter R is equal to small letter P divided by the sine of capital letter P is equal to the ratio small letter Q divided by the sine of the angle capital letter Q. Remember, the small letters represent the sides which are opposite the angles R, P, and Q respectively. As I said, it can be remembered in two different ways. You can even have these denominators as the numerators, while these numerators can appear as the denominators respectively. We have three ratios, out of which we are going to use 2 when we look at what we have to find and what has been given. We have been asked to find RQ. RQ is opposite capital letter P, meaning it is denoted by small letter p. So we must have that involved. This RQ is opposite to the angle at P, which is given as 60. So the sine of P is also going to be involved. Then we have been given PQ as 5 centimeters. which is opposite capital letter R, meaning it is small letter r, so that is also going to be involved. And in this case, the angle R is also given, so that is also going to be involved. So we will remove this part and just make use of the first two ratios. What we need to do at this stage is simply to substitute. Where there is R, we substitute by R, which is 5 centimeters, divided by the sine of the angle at R, where the angle at R is 50 degrees. This is equal to P is what we have been asked to find, so it will remain as P. But the angle P is known as 60 degrees, so we substitute sine 60 degrees. We must make sure that P stands out alone on one side of the equal sign. What are we going to do? Excellent. Because P is divided by sine 60 degrees, and the inverse operation for division is multiplication, we are going to multiply both sides of our equation by the sine of 60 degrees so that P can be the subject of the formula. So on the right hand side, we multiply by the sine of 60 degrees. To balance the equation, on the right hand side, we must also multiply by the sine of 60 degrees. So that sine 60 and sine 60 we will divide, meaning the right hand side will be P. On the left hand side, that is where we are going to have 5 centimeters multiplied by the sine of 60 degrees, and everything is divided by the sine of 50 degrees. At this point, you have to use your calculators to multiply 5 centimeters by sine 60 degrees divided by the sine of 50 degrees. And remember, your calculators must be in the degree mode, because if the calculators are not in the degree mode, you will be getting solutions different from the ones that we are getting. So make sure that your calculators are not in the radian mode, neither should they be in the gradient mode, but in the degree mode. So work with 5 centimeters by sine 60 divided by sine 50, and let me have the answer. Good. After this has been calculated from the calculator, you must be in a position to get 5.6 centimeters. This is what P is equal to. And this small letter P, as we have agreed, is the one representing the side QR, which is opposite capital letter P. So at this point, we need to conclude and correct this answer to 3 significant figures. So therefore, RQ is equal to 5.65 centimeters. That is to 3 significant figures. So the sine rule has been used to find a side in a situation where 2 angles are given and the side is given. Let's move on to another example where now we are going to use the sine rule to find the size of an angle. Now, let's look at our second example, in which we have been given a triangle DEC with DC as 12 centimeters, CE is 10 centimeters, and the angle at D is 45 degrees. We are required to find the size of the angle DEC. I want you to state the sine rule, but in this case, you must have the sines of the angles as the numerators. Exactly. In this case, it will be the sine of D over the side D is equal to the sine of the angle E over the side E, and this is equal to the sine of the angle C over the side C. Now we compare this with the information that has been given so that we see which one is going to be left out in our analysis. The angle at D is given as 45 degrees. The side D, which is opposite to the angle D, is given as 10 centimeters. We have been asked to find the angle at E, and the side opposite to that angle E is given as 12 centimeters. So the third ratio will not be used in this case. We are just going to use the first and the second ratio. We do the substitution. D is 45. So sine of 45 degrees divided by the side D is 10 centimeters. This is equal to the angle at E is the one we must find. So the numerator remains as the sine of A divided by the side E, which is 12 centimeters. Like in the previous case, we must make